we'll explore redox reactions, short for oxidation reduction reactions. These are chemical reactions that involve the transfer of electrons. Examples of redox reactions in everyday life include photosynthesis, where plants convert carbon dioxide into sugars for energy, and aerobic cellular respiration, where animals break down sugars to release carbon dioxide. Combustion reactions, like those seen in fire, are also redox reactions and are chemically similar to cellular respiration. Batteries power electronic devices through redox reactions as well. Other examples include rusting of iron and tarnishing of silver, and the patina on the Statue of Liberty, which is made out of copper but appears greenish blue due to surface oxidation. Even apples turn brown when exposed to air in a redox reaction called oxidative browning. This can be slowed by dipping apples in orange juice or other liquid containing citric acid. Citric acid is an antioxidant which helps prevent oxidation. Redox reactions, short for oxidation reduction reactions, involve the transfer of electrons between reactants. Oxidation refers to the loss of electrons, while reduction refers to the gain of electrons. A helpful mnemonic device to help remember this is oil rig. Oxidation is loss, reduction is gain. Another common mnemonic device is Leo the lion says grrr. Lose electrons equals oxidation, gain electrons equals reduction. It's important to note that oxidation and reduction always have to happen together. Personally, I like to think about the everyday meaning of the word reduction, to go down. Since electrons are negatively charged, gaining electrons lowers an atom's oxidation state, which we call reduction. Conversely, losing electrons increases the oxidation state, which is oxidation. This number line helps illustrate oxidation and reduction through changes in oxidation states. For instance, if an element goes from being +5 to being +3, its oxidation number is decreasing. This means that it is being reduced. On the other hand, if an element goes from being -4 to -2, it's becoming more positive. The oxidation number is increasing, so the element is undergoing oxidation. Always track how the charge changes to determine whether a substance is being oxidized or reduced. Combustion is a specific type of redox reaction. In a combustion reaction, oxygen gas acts as a reactant. It reacts with carbon to form carbon dioxide and with hydrogen to form water. Oxygen can also react with elements like sulfur or nitrogen to produce their respective oxides. Oxidation is sometimes described as the gain of oxygen atoms because oxygen is highly electronegative and tends to pull electrons towards itself. This makes the atoms it bonds with more positively charged. A common example of a combustion reaction is the reaction of octane, C8H18, a component of gasoline, with oxygen. This reaction produces carbon dioxide and water. In fact, regardless of which hydrocarbon is used, whether it's propane, butane, or methane, the combustion products are always carbon dioxide and water.